Okay, so what we're talking about today is something called gram formula mass, and it also goes by the name of molar mass. I like molar mass a little bit better because to me that explains what this is or what are we talking about. We will start with some examples. First thing we need to know to be able to calculate a molar mass or a gram formula mass is how many atoms of each kind of element are in the compound. So if you're looking at a formula, you need to be able to decide how many of each thing is in that formula. So for this formula, how many sodiums are there? One. How many chlorines? One. That's pretty straightforward. One of each. How about the next one? How many irons? Two. How many oxygens? Three. Oh no, this is example 2 on your notes packet. And then the 3 that's next to it, what's the Roman numeral for? What's the Roman numeral tell you?
It's iron 3.
It's iron plus 3, right? That's the charge, not how many irons there are. So it's good that you pointed that out. That's the charge, not how many irons there are. There are 2 irons because you have to balance the plus 3 charge with the minus 2 charge of oxygen. So 2 irons and 3 oxygens. You may want to jot down the formula right next to your examples. Maybe that would help a little bit. Okay, let's look at this formula. NH4 2S. Remember, anything that's outside the parentheses has to be distributed, just like you do for math class. So how many nitrogens are there? 2. How many hydrogens? 8. Because 4 times 2 is 8. How many sulfurs? 1. Al2SO4 3. How many aluminums? 2. How many S's? 3. How many oxygens? 12. Okay, very good. Now that you can figure out how many of each atom are in the formula, we can move on to finding or calculating the gram formula mass or the molar mass. The gram formula mass is the mass in grams, makes sense, of 1 mole of an ionic compound. And that's where it also gets the name molar mass. When you're talking about an ionic compound, the molar mass, what is the mass of 1 mole of that compound? So gram formula mass and molar mass mean the same thing. What is the mass of 1 mole of that? You kind of already know how to do this because we've already done this for elements. What's the mass of 1 mole of neon? Where do you get your gram numbers? From, I see you looking, from the periodic table. So the mass of 1 mole of neon, 20.18. What's the one you used yesterday in your lab? The mass of 1 mole of magnesium. (24.31). So what do you think we would have to do if we had a compound? Add them all up. That's just what makes sense, right? We already know how to do molar mass of elements. You just look at the periodic table. So if you're going to do a mass of a compound, it would make sense, look at the periodic table and add up all of those pieces. And that's exactly what you do. Add up all the pieces of the compound. If you've got a calculator handy, you may want to pull it out so you can play along. we're going to do some examples. We're using the same formulas that we already used at the top of the page. So how do we find the molar mass, or the gram formula mass, of NaCl? Look at the periodic table, and you would add up 1 sodium and 1 chlorine. What's the mass for sodium? 58.44. Oh, total, 58.44, that's our answer. What's the sodium one off the periodic table? 22.99, and then chlorine you'd look up is 35.45. So then, when you add it together, you get 58.44. Units for these are the same as the units were when we just did this for elements, and that's grams/moles, because this is the number of grams in 1 mole of that compound. And if you would like to jot yourself a little note about sig figs, we are going to keep these to 2 decimal places. The reason we do that is the periodic tables that you have on the back of your notes packet, the ones you will get for the test, pretty much everything is 2 decimal places. And then when you add, you keep the least number of decimal places, which should be 2 anyway. So we'll just make that our rule of thumb for these. Molar masses or gram formula masses should be kept at 2 decimals. Okay, let's do the next one. Fe2O3. Look up the mass for iron and multiply it by 2, because there are 2 of them. Look up the mass for oxygen and multiply it by 3, because there's 3 of them. Add those things together. You should get 159.70 grams per mole. If you are using the periodic table off of your planner, you may find that your numbers come out just a little bit different. The planner rounds differently than the ones on the back of your notes packet. Okay, let's do the next one. NH4-2S. Look up nitrogen, multiply it by 2. Look up hydrogen, multiply it by 8. And add 1 sulfur to that. Total, you should get 68.17 grams per mole. And one more of these. Al2SO4 3. Look up aluminum, multiply it by 2. Look up sulfur, multiply it by 3. Look up oxygen, multiply it by 12. Total, you should get 342.17 grams per mole. Do we have questions so far? All right, so what do we actually use these for? We can use gram formula masses or molar masses just like we did the ones for the elements. So if you think about the lab calculations that you did for your magnesium lab, you had to find out what was the moles of magnesium reacted. So you changed grams to moles, and you use the molar mass to do that. We can do the same kind of calculations for compounds now that we know how to find the molar mass for a compound. So use your calculated gram formula mass to do mole conversions. The actual calculations on these have not changed. How you do mole conversions has not changed. We're just adding a new number to the things that we have in our toolbox to choose from for how to do these. So questions for these calculations still sound the same as they always have. How many moles is X number of grams of this compound? These are the kinds of questions that you're still going to be able to answer. The only thing that we've changed is we've swapped compounds for elements. If you turn that question around and phrase it the other way, what is the mass of X number of moles of this compound? This is what the questions will sound like. And it's the same that we've been doing since Unit 3 last semester. We've just swapped compounds for elements. So let's do a couple examples. How many moles is 2.63 grams of NaCl? What are we given in the question? The grams. So we're going to start with 2.63 grams. Remember, you can put the given over 1 if you want to. Make it a fraction. Set up for your next fraction, we need to cancel the grams, so where do they go?
On the bottom.
On the bottom. And we need the number of grams of NaCl.
58.44.
58.44. We already calculated that. And this is the number of grams in how many moles? 1. So we put 1 mole on the top. The grams cancel. We're left with moles. Now we just need to do the math. Is this multiplying or dividing? Dividing, because you got 1 on the top and 1 on the bottom. How many sig figs should we keep?
3.
3, because the first number has 3. And you should get 0.0450. Remember that the zeros in front of the 4 do not count for sig figs, so you have to have that 0 at the end. Let's do one more. What is the mass of 3.78 moles of Fe2O3? Start with what you're given in the question. 3.78 moles. We need to cancel the moles, so where do they go next? On the bottom. What are we looking for? Grams. So that's going to go on the top. So we have 1 mole of Fe2O3 on the bottom and 159.70 grams on the top. How many sig figs should we keep? 3. Now, I have seen students make mistakes in the past by leaving off this 0 right here at the end. If you left off that 0, it potentially, not in this one, but it potentially could throw off your sig figs. So you need to keep those zeros. You can't just leave them off. In this calculation, it wouldn't matter, but that's not always going to be the case. So you need to keep those zeros, even though it may not look like you need to keep them. Should have 3 sig figs here, 604 grams Fe2O3.